Okay, so we're going to take a look at the printer now, and a few more things. I might jump back and forth between what you're seeing on the computer monitor and the video camera. There's one more thing I wanted to show you. After we slice our part, this last line here is interesting. It estimates the amount of filament we'll be using. And so in this case it's 63 cubic centimeters, or 63.7 grams. And so we can just simply calculate the cost. If we have a 2.2 kilogram spool at $35, we can do the math and figure out how much this part is going to cost us. And so now I'm going to cut away to the printer itself. Okay. So here's the general setup here. We have the print bed, the extruder. This extruder moves along the y-axis, and then these threaded bolts on each side, each driven by their own motor, actually provide lift for this along the Z. The bed itself, the extruder moves along the X and the Z, and then the bed itself moves along the Y. So there are some customizations that are here, including this spool holder. This is nice because it keeps the spool right above the extruder, but if you have any entanglement causing a jamming, if the force that it takes to pull this spool and advance it can actually pull down this spool holder, causing these bars to bend in slightly, which then jam the extruder head right into the part and can cause it to get knocked off axis. So I also have this long rod hanging from the ceiling on which I can have more spools. And this spool holder up top here is not attached to the printer itself. So it's a lot less likely to get it to cause it to knock the printer off axis. So what we have here is a heated bed. There's circuitry that goes under this glass top. And the first thing we're going to want to do is power this up. And in the back we have a circuit board with a dedicated fan to that, and that's the fan you're hearing there. There's also another fan here to help keep the extruder tower cooled. So we do have some options in the firmware. Including the calibrating the Z-axis, some manual settings that we can control from our software, but that we can also control from here, including heating up the extruder, accessing the SD card to print from there, the fan speed, and some other configurations. The first thing we want to do, and I'll cut back to the computer screen for this, is we want to home the extruder. But before we even want to do that, you can see I have some filament here from the last print job that's just on the edge of it. It looks like I was able to knock it off. So we want to do that. Oh, actually, we're going to need to cut back to the computer screen, and actually we need to connect to the printer. So power that down. Fire it back up. Okay. And then in the upper left-hand corner, click Connect. Okay. So if I click on this button right here, I'm homing all of the positions. Any other button homes the respective X, Y, or Z values. But if I want to home all three, it'll get the printer into this home position, the front left. And you can tell I could use a little bit of oil here on this rod to keep down on it, keep that squeaking down. Okay, so now to level your printer, what you want to do is have a standard piece of paper, printer paper. Grab one of those, and then you want to fold it in half so that it's 2 layers. And now slide it under the extruder head, and you should be able to move it back and forth with some resistance from the extruder head. So again, it should be enough so that you can move the piece of paper, but not enough that you don't feel any friction with the extruder head. And so you want to have the same amount of friction all over the print bed. Now if you find that you have a general all over the bed sort of the extruder's too low or too high, you can come in here and calibrate the Z position by either taking it up or down. We're going to leave it as is. Now, for instance, over here in the upper back right corner, I have a little bit too much friction. So what we have here, we have 4 set screws with springs on each of them. And on the back right, what I can do is just torque this one down just ever so slightly, and then check again until I have an equal amount of pressure, consistent amount of pressure across the print bed. Okay. So once you have an equal amount, you want to home the printer again. And if we can just cut back to the computer monitor one more time. Quite simply, we already have this sliced. We already have our G-code generated. And so we're going to click on Run Job. And you notice something started happening here. If we cut back to the camera, you see this indicator light came on, indicating to us that current is moving to the print bed, and it is being heated up. So first, the print bed will be brought up to a temperature of 50 degrees Celsius. Once it reaches that temperature, it will maintain the temperature, and then also the extruder will start heating up to the set temperature around 200 degrees Celsius, something that we defined in our slicer settings. Once the extruder and the bed are both up to temperature, then the actual print process will take place, where we have our 3 loops for a skirt, and then the actual layers will start to come up. One thing I didn't show you is that if you want to surface prep, and before we actually hit the run job, we could use some tissue and any type of alcohol solvent can be used just to wipe down that glass surface and have that ready to go. If we have any kind of oils on that glass surface from our hand, then the extruded filament will have a tough time sticking to it. So right now you notice that it rehomed itself. That's because the bed temperature, the bed got up to temperature, and now we have an intermittent light telling us that it's just holding it at a 50 degrees Celsius. There's not a constant current required in order just to hold the temperature. and we heard a second fan kick on. That's because the extruder is now being brought up to temperature, and this fan here, which is pushing air out that way, pulling it in from these slots. On the other side of these slots is the actual filament being fed in with a stepper gear rotating this way, combined with this pressure of this ball bearing. So this spring is applying pressure towards the gear head. So the gear head locks against this ball bearing, the gear drives downward, forcing the filament down, out, and through the extruder tip. And this extruder tip is the only thing being heated right now, up to about 200 degrees Celsius. So the idea is that the filament does not get up to this temperature until it's fed into the hot end. This tip right here, and there should be no heat in between anywhere except there. But heat does creep upwards, and to mitigate that, that's where this cooling tower and fan comes in. So we're almost there. Now you can see our temperature is reaching up to just passing 200 degrees Celsius, and just a few more seconds and the process will begin. You can see it can take a few laps without any actual filament coming out of the extruder head. That's why we put 3 down for that skirting. Okay, so this is interesting. So right now, there's absolutely no filament coming out, and I'll tell you what, so what we want to do right now, we'll cut back to the computer monitor, and we'll click Kill Job. And that will come back to the camera. Now the first thing I'll do is actually just push down, apply pressure on this spring to release the ball bearing, pull this out, and what had happened from a previous print is that during the cool down period after the job was done, heat continued to be fed up the filament, causing a swelling here. And this amount of swelling was enough so that it would not be able to be fed down into the extruder shaft. So in addition to changing this out, I'm also going to change to a white filament, so it's easier for us to see rather than that red filament on red base. So and what we're going to want to do here is, just to ensure we have a clean end here, we're just going to break this. I'm just going to break this off with my hands. It just snaps. So this is an interesting experiment, how to 3D print with one hand, but we'll do it. Oops. Next thing we want to do here is straighten out some line. When this filament is created, it itself is extruded right onto these spools, so it really saves its shape when it's being thermoprocessed. And we want to put it in the same way that we took it out. So insert and then apply pressure on the spring. Now for this part I'm going to have to set the camera down, so stand by. Okay, well, I could not get the filament to go back down into the drive, so I took this opportunity to expose the gear, the drive gear that drives the filament, and I don't see anything that's in the way. Sometimes you'll have some obstructions here. Let's see if we can get a light on that. But I don't see any obstructions, and so what we're going to do here is, and here's the part that I took off. So you can see how this slips on here, and it forces the ball bearing against the drive. And the filament sits right in here and goes down there. So we'll put this back together again first. Okay. So let me go back to the computer and actually heat up the extruder. Let's do this process hot. And so if we're looking at the computer screen right now, what I do is manually click on heat extruder. Okay, and now we can see that it's going to heat that up to 210, which is just a default right now for us, our working temperature. So we'll wait till that gets up to about 170 or 180, and then we'll be able to press that filament through the extruder head and then reassemble this piece. And while I do that, I'll turn the camera off. But basically there's a screw that goes through this piece and holds it in there. So, alright, so when we come back, we'll have this all reassembled. We'll have the filament going through. Everything will be working. Okay, so we've got the filament fed back into the extruder. And what we're going to do here, just to ensure that we have a good feed, I'm going to cut to the computer screen here. And first of all, we'll get the extruder into the home position. Then we'll raise it up about 30 millimeters here. And now I've got the extruder manually heated, and we're going to extrude this 30 millimeters. And right now, we look at the extruder, and we can begin to see nice clean flow there. It doesn't go off to the side, it goes straight down, comes out at a nice consistent rate. So then let's turn off the extruder heat, and back to the printer again. Once this stops flowing, we'll just pull this away, clear that off, and then again, just like we were, we'll now run the job, and the printer bed will start to heat up and get up to temperature, and then it will home the position of the extruder. The extruder will come up to temperature, and I'll cut away in between now and then. Okay, our bed's up to temperature and our extruder is just about up to temperature, and it's going to start here in just a second. Okay, now we're getting a solid line there after the first loop, so it's good to go around 2 or 3 times. So that's the skirt, and now we're actually printing the exterior of the first layer, the perimeter of the first layer. prints the inside perimeter first, and then 2, and then 3 would be the final perimeter. And now for the bottom 3 layers are all solid, even though I've got the infill set at 40% density. And we'll be able to see what 40% density looks like on the 4th layer. But the first 3 layers and the top 3 layers are going to be 100% solid infill, and that's what we're seeing here. So right now, if we cut back to the computer screen, we can actually see the progress of our G-code and a temperature, an estimated temperature of the filament that's being laid down. So if we wanted to, we could view this computer screen remotely, but we need to remember that even if our piece fouls up and becomes off track, or if filament stops being extruded, this picture will remain the same and it'll continue nonetheless. So we don't really need to count on this, but it is a good estimation. If you're wondering where you are in your print, what you can do is click the object and then go back to here, so we can get an idea of how much time we have remaining, and etc. Also, there is a print job estimation of time, which is based on our feed rate. So I'm still on the computer screen here, and what we could do, I could turn this feed rate up to 150%, which basically accelerates all the speeds we have in place to a factor of 1.5. And I'll do that now. I'll place this manually. I'll type in 150. And now if we see the difference in the time cut drastically by over 25%. And if we cut back to the printer, now you can see it's printing faster. And we heard that also in the frequency, the sound actually given off by the stepper motor, a higher frequency. And this is printing the 3rd layer. This printer can handle speeds up to 200 millimeters a second. And that's filament leaving the extruder head, 200 millimeters a second. Or actually that's movement speed, right? Right now we're going at about 60, we're going about 90 millimeters a second, and that's the actual movement. I apologize, it's not the amount of filament coming out of the extruder head, but it's the travel speed. So right now this extruder head's traveling at about 90 millimeters a second. Now there you can see that that 40% infill. You see how it's taken large gaps now. I know it's hard to show up until you get a few layers down to really see the effect of that 40% infill, and especially it being the same color on color. But you can see how it's taking basically it's not putting filament down over 60% of the area, okay? So in this way we can drastically reduce material costs and print times by having if we're just printing a prototype and we don't need a 100% densely filled working unit, then we can do this to cut costs and time. So this is scheduled to print for another 2 hours and 57 seconds. And what I'll do is I'll come back here in the middle of the print and then at the end of the print with more film to round out this video.